Hi, I'm Mr. Meyer. In this video, we're going to look at counting protons, neutrons, electrons, mass number for ions as opposed to just neutral elements. So let's start out what an ion is. An ion is an atom or group of atoms that has acquired a net electric charge by gaining or losing electrons. Okay, so electrons are gained or lost depend on charge, or maybe charge depends on if electrons are gained or lost. So let's just look at an example here how that would work. So we're talking about ions here, and I'm going to go to this element sodium. And if we look at the periodic table, we're going to see that its atomic number is 11. Okay, and because its atomic number is 11, it's going to have 11 protons. But notice it says it's a sodium ion with a plus charge. So you're given that it's a plus charge, which means that it's going to either gain or lose electrons. Why are electrons gained or lost? It's because protons and neutrons are in the nucleus, but electrons are outside the nucleus. And so they're easier to grab those or gain those or lose those. We're going to find out in some reactions where those are shared. So what happens is sodium actually loses an electron, and it has 10 electrons, and this actually makes it stable. Now, why, if it loses something, does it have less electrons and protons? It loses something negative. So if I look at it and say, hey, it lost an electron, it has 11 positives, 10 negatives, so the overall effect is that it has a +1 charge. Okay, everything else is the same as we did before. The number of protons, 11, plus the number of neutrons, 12, equals the mass number of 23. Let's look at magnesium. Magnesium has a charge of +2. Magnesium is number 12 on the periodic table, so it would have 12 protons, and the +2 charge means it actually lost 2 electrons, meaning there are 2 more protons than electrons. Okay, and then 12 protons plus 12 neutrons gives me a mass number of 24. Okay, let's do some negative thinking and think about the fluoride ion. Fluoride ion is F minus. Fluoride on the atomic number has a 9 there. 9 is the atomic number, so it has 9 protons. It has a negative charge because it gained 1 electron, so now it has 10 electrons, 1 more electron than proton. So therefore, it has the -1 charge. If we're trying to figure out the mass number, 9 protons plus 10 neutrons gives me 19 for its mass number. So using that, you can complete this chart. Here's just a little story and a reminder to remember that positive ions lose electrons and negative ions gain electrons. So I have it right here. We have a sodium and potassium, or I'm sorry, sodium and magnesium. They're walking down the street, and the sodium says, hey, I think I lost an electron. And the magnesium says, are you sure? And the sodium says, yes, I'm positive. And the magnesium says, I'm positive too. So there's your story to remember that when you lose an electron, you actually get a positive charge because you're losing something negative. When you gain an electron, like in, let's see, chloride, you have a negative charge. So I'm just going to do a screen share and connect this to the periodic table because I'm noticing a lot of these things have 10 electrons. Why is that? So bear with me as I do a screen share, and hopefully I can find this here in my documents. Let's see. A periodic table. Now I kind of threw some numbers up on this periodic table, and what we have is we have our families here. These are the alkali metals, the alkali earth metals. These are transition metals. We won't do as much with those. And then we get over here. Notice this line right here. Everything to the left of this jagged line are metals. So it's kind of like the ocean on Earth. About 3/4 of our surface is covered with metals. Okay, just like 3/4 is covered with Earth is covered with water. Okay, and then these would be non-metals right here. And then these gray ones are kind of borderline right here. Notice hydrogen is a lot like this family. but it's actually a lot like this family over here. And I would actually, some tables put it right here. It's actually considered it's not really considered a metal. So I would put that right there sometimes. Okay, this family is noble gases. We talked about that number of 10. For some reason, having 2 and 10 and 18 and 36 and 54 and 86 helps you feel your shells or rings or energy levels, and that creates more stable things, and these things don't react. So what happens is anything in this halogen family where it's going to gain 1 electron to become like this. And that's why it has a -1 charge. Anything in this family is going to gain 2 electrons to become like a noble gas. Anything in this family is going to gain 3 electrons to become like this. Okay, and I guess you could think about this gaining 4 electrons, but it probably becomes more sharing when you get over here. Let's go the other way. Sodium would actually lose an electron to have 10 and become like neon. So that's why this family all has +1, because they would all lose an electron and become like the nearest noble gas. Magnesium would lose 2, aluminum would lose 3. If you get into these here, it gets more confusing because there are sublevels and things to keep track of. So you'll always be given the charge on these. But I wrote these charges above, which are common charges above these different families to help you out. And we're going to start to make that connection as we work through the periodic table. All right, finish page 8 and good luck. Thank you.